Midpoint is definitely one of my favorite concepts to teach. It is so conceptual the way that it will be developed in this video, and I'm really excited to share that. So let's begin. Take out these two number line segments. Think of them not as infinite number lines, but just segments that are finite of, let's assume 4 units. It looks like each one is 4 units. One of them I want you to associate with the x-axis horizontally, and vertically I want you to associate that with the y-axis. Great. So my first question is, I don't know how I'm going to do this. Okay, I'll try some things. Is this the midpoint? Is this the midpoint of the segment? The answer is no. Is this the midpoint of the segment? No. Is this the midpoint? 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 Yes. Great. So I'll label it just to give you a definition if you weren't familiar. I probably won't do that again. But let's label it right here. I'll use the letter M to indicate a midpoint. Don't confuse that with M for slope. All right, not to be confused with M for slope. So we'll say that's the midpoint, because that's the same thing as a point of symmetry in this case. All right, this is the point of symmetry for that line segment. We will refer to it as the midpoint. Excellent. So where's the point of symmetry here, or that midpoint? It'll be right there. Again, I'll just label that as M. Great. Once you get that idea, let's do some practice here and see if we can go pretty quickly with this. We have midpoints with actual values labeled from 0 to 8. What's the point of symmetry? Where's the midpoint located? Great, when M equals 4. All right, how about the next one? What's the point of symmetry here? When M equals -5. Excellent. What's the midpoint here? This is 3. Great. What's the midpoint? That's actually 20, 0 and 20. What's the midpoint between 0 and 20? It is 10. What's the midpoint here for -4 and 0? It is -2. And lastly, what's the midpoint for this one? It is -6. So I hope that we were able to do those pretty quickly in our head. And they were specifically designed that way, because what I want to compare these two in the next few examples is, and take a look at that and think about this question. What was special about these 6 number line segments that made them pretty easy to figure out? And let's compare to the type of problems I'm talking about. So suppose instead we did something like 2 to 12. And -9 and 5. What is the midpoint between those? So let's see if we can do that in our head pretty quickly. What's the midpoint between 2 and 12? I'm going to give you 3 seconds to think. 3, 2, 1. What's the midpoint? It's a little bit hard, right? I don't know. Some of you were able to figure out, and probably you're still thinking about it and realize, oh yeah, the midpoint is 7. But this one was not so easy to figure out. I probably won't even write the answer down. But what's the midpoint for this one? I'll give you 3 seconds to think about it, and let's check. 3, 2, 1. And what's the midpoint? It's not that easy to figure out as the previous ones, right? But if you're still thinking about it, and some students do know how to do this pretty quickly, you may be one of them, then you know, oh, the midpoint is just -2. And I want to show you a way to be able to do that very quickly. But the main question to think about is, what made the first few very easy? The first 6 here already highlighted in green. It was that very key number associated with very easy problems is involved. Notice it's 0 and 6, -12 and 0, -10 and 0. Is 0 involved with the last 2 examples? No, so 0 is not involved here. Therefore, they're not that easy to figure out. Zero is not involved, and all the previous 6 problems, it's involved in every one of them, which made it very easy to figure out in our head. So that's what I want you to think about. How do we get the 0 involved in this problem here from 2 to 12? How do we get this 0 involved in this problem from -5 to -9 to 5? So let's check that out in the next part. Let's explore a little bit, and I've written the question ahead of time. How do we get that 0 involved? That's the main thing we want to have in mind at this point, right? It won't be something we do all the time, but to understand the concept, I do want you to think, how do we get this 0 involved? Let's just take a look at these two number lines without any values labeled and just talk about symmetry. All right. So I want to use different color here. Let's go with blue. And suppose that, again, this is the segment given. It looks like the midpoint is right about there. As a matter of fact, I wanted to do that one in green still. Yeah, let me use different color for different parts of it. This is still going to be the midpoint. Do you agree? The second segment, it looks like the midpoint is right about there. Nothing out of the ordinary that we haven't discussed yet. But we're going to start changing this segment. Let's start with the top one, and I'll show you what I mean. Suppose that, and again, we will assume that there's 4 units to the right of the midpoint, and it looks like 4 units to the left of the midpoint. This one's drawn to scale. Great. So suppose that on the right side, we were to extend 2 more units to that segment. Now the endpoints are here and here. Now, is this the midpoint of our new created segment? And the answer is no. You can probably see there's 6 units here and 4 here. That's obviously not the midpoint. The question is, what would we have to do on the left side to compensate and maintain that point that we labeled in green before as our midpoint? Whatever we did on the right side, it looked like 2 units. Let's do that on the left side. If we extended that segment by 2 units on the right side, let's do the same on the left side. And the question is this now the midpoint of our previously drawn segment and our new extended segment? And the answer is yes, it's the midpoint of both. All right. So we can see that this is an idea that's going to help us. And what's the opposite of extending that segment? Making it longer or making it shorter? Which one do we want to think? All right. We want to now, rather than extend it, we're going to remove units from this. And I'll use red for that to indicate that we're removing something. So again, it looks like 4 units to the right, 4 units to the left. But now we're going to say this red represents, now I'm cutting one of those, I'm removing this part out. Think of it as cutting it and it's gone. It's not part of that segment anymore. So this is our new endpoint. And maybe so it's easy to see on the eye. Let's say we can remove 2 units. Yeah, so it's very clear to see that now we're looking at analyzing, is this endpoint and this endpoint still going to maintain that previously labeled midpoint? And the answer is no. You can see there's 2 units here and 4 there. So therefore, what should we do on the left side to compensate for removing 2 units? If we remove 2 units before on the right side to maintain that symmetry, we're going to remove 2 on the left and bring the segment now to here. These are our new endpoints. So the question is that green point still the midpoint of this newly created shorter red segment? And the answer is yes, but it's also the midpoint to the previously in gray segment. So that's what I want you to see. That idea of, I'm going to call it or refer to that as extending or cutting the segment. So let's say cut or extend the segment. That's going to be a key thing. Follow thought to this question. How do we get this involved? Let's either cut or extend the segment. And let me show you what I mean by that. We're either going to cut or extend the segment. Let's look at the 2 problems from before. Remember the 2 and the 12 and the -9 and 5. Let's see what I mean by cut or extend the segment. The question is 2 and 12. Remember, what made the previous 6 examples really easy is that there was a 0 involved. And my question is, how do we get a 0 involved in this number line? Where is the 0? Visualize where on this number line, if we have the option to extend or cut, where would the 0 be located? Is it inside of the number line or is it outside of the number line? Meaning we would have to extend that number line. And that's what it looks like, right? 2 is positive and 12 is here. So it means that 0 was somewhere to the left. And I will use that color again. Now this time they're not drawn to scale, but suppose that we extended it to get the 0. 0 is here now. How many units did we add on the left side? From 0 to 2 is 2 units. So therefore, how many units do we have to extend on the right side? 2 units. I'll do my best for it to look like it's symmetric, but there's the idea, all right? So If we added 2 units to the right, what's our new endpoint of the segment? It is 14. And notice how now we have a new problem involving 0. What's the midpoint between 0 and 14? Now we know very quickly that's got to be a 7. And I hope that's the answer I mentioned earlier when I was checking my work verbally. But that's the way that you can think about it. It's not something we're always going to be drawing, but that's the idea behind the concept. This is the picture behind the concept, which we will no longer do, but arrive at a shortcut, I think. Okay, and let's look at the next one. -9 and 5. We want to get the 0 involved. Think about where along this segment is the 0. Is it inside the segment or outside of the segment? -9 and 5, it looks like we crossed the boundary. So 0 is somewhere inside. Is it closer to 5 or is it closer to 9? Because that's the one we're going to begin with, okay? Always begin by labeling your 0. 0 is closer to 5. So that means that somewhere here we're going to remove how many units? This is 5 units. 5 units. These 5 units will be removed from the line segment. So that means that we have to remove 5 units from here. And -9, removing 5 units from the left side means that we're going to end up at -4. And now we have a new problem involving 0. What's the midpoint between -4 and 0? It's got to be a -2. And I wonder if I said that earlier when I was checking my work. -2. You can count the number of spaces between each one if you would like, but not drawn, like I said, not drawn to scale. All right, let's analyze the next one. Should we extend or cut the segment? Think about that. And identify the 0. We'll let you know what we need to do. 0 is because this number is negative and this one's positive, that means that 0 must be somewhere inside there. And it looks like a lot closer to -4. So that's where I will begin. We're going to remove 4 units on the left side. So now I'm starting on that part of the line segment. I hope you can notice those differences. 0's right there. Removing 4 units from the left means we have to remove 4 units from the right. And what is the new number associated with 0 now? It is 16. So that means that our new easy problem has a midpoint of 8. And hopefully you can see how to do that really quickly once you identify the 0 and 16. Next one is -20. First endpoint is negative, second endpoint is negative. That means that because the sign didn't change, 0 is not inside of the number line, but rather outside. And which one is it closer to? It's closer to the -6. So that means that we must extend the segment from -6 all the way to 0. That's a total of 6 units on the right that we need to compensate for on the left side. So let's extend that segment to maintain symmetry. And if we go 6 units, start at -20 and go 6 units to the left, our new endpoint is -26. Our new problem involving -26 and 0 can now be done very, very rapidly mentally. And we get a -13. All right, just for the purpose of speed, I'm going to draw these a little bit quicker. But I want you to think about what's going on here and start looking for a shortcut if you're not familiar with it yet. Next one does cross the 0 boundary because it goes from negative to positive. So therefore, I will use red to indicate we're cutting 0 somewhere right there. So we're removing 10 units from the right side. Let's remove 10 units from the left. That will now take us to -30. Right? Check your work right there. And we know the midpoint for this one is now -15. How do we get that? It's a good question to ask. Just divide by 2, right? How do we get -13 here? Divide the -26 by 2. And last one here, in terms of me drawing, I will stop drawing the extend or remove the segment part, but I did at least 6 examples so we can ask key questions. And hopefully make key connections to this concept. All right. So because 0 is outside of this line segment, we're going to add 3 units to the left and 3 units to the right. Whoops, that's not what I meant to write. What is, I'm thinking of the value already. What is 3 units to the right of 27? It is 30, and therefore we can see that this one has a midpoint of 15. All right, for the context of what we're going to be doing in the future with this series, it's normally going to say x equals 15, x equals negative 15. It's going to represent a vertical line, as we've done line of symmetry already. That's what I'm trying to tie this lesson to. Okay, so let's start asking those key questions, all right? How do we get the zero involved? That was the first one, and the answer was by cutting or extending the segment. My other main question, I guess I'll write in a different color. Another key question to think about is, how do we quickly get the other number associated with zero so that we don't have to draw this every time? Let me rephrase that here. How do we quickly get that number associated with zero? Well, let me show you if you haven't seen it yet. It's really easy to find. Get number associated. All right, and think about that. I won't write the answer down in words, but I will show you how to do that and lead you there. Guide you to that thought process. So let's analyze number line per number line that we did here. All right, the question is, how do we quickly get this 14? I'm gonna give you a little hint. Look at the information that was given at the beginning of the problem, which is shown in gray. Do you see a 14 hidden in our original given information? All right, and hopefully you can see that. I'll guide you there with the next one. All right, how do we quickly get this -4 that made the problem really easy? Now look at the given information in gray. Do you see a -4 hidden in what was given in the initial gray colors? Same thing here. All right, how do we get the key number associated with zero, this 16? How can we quickly see that in the given information? 20 and -4. Do you see a 16 there? And same thing here. The initial information was -20, -6, and our key number associated with zero is -26. Do you see a connection between those three? And do you see a connection between those, the 10, the -30, and the 40, all right? And just the same as before, I guess, I've asked that question too many times already in this video, but it doesn't hurt to reinforce it, all right? How do we quickly identify this 30 from 3 and 27, which were the original given values? And let's start answering that question. What did we do with 3 and 27 to get a 30 mentally? Add. What can we do with -40 and 10 to get this -30? Add or combine. That's another acceptable really way of saying it. How can we get a -26 with the given information? Combine or add them. You see what I'm saying? This is the same idea for each one of them. How do we get this 16? By adding 20 and -4. How do we get this -4? By adding -9 and 5. How do we get this 14? By combining 2 and 12. So that's the main idea, all right? We're going to combine, maybe I will write it in down here. We're going to combine endpoints. But is that all we did? Combine endpoints. You can even say add. Combine endpoints. And what did you do to the -4 to get a -2? Divide by 2. How do we get an 8 from 16? Divide by 2. What do we do to -30 to get this midpoint? Divide by 2. So combine the endpoints as number one part of the answer of this key question above, and then divide by 2. Students that are familiar with the vocabulary, I don't make them write this down in their notebook right away. But if they're familiar with that, that's just known as taking the average. This process is known as taking the average, adding something and adding two values and dividing by 2. So taking average, I'm just gonna accept that average. No, that's not true. Let's fix it. Because it's important, it's key vocabulary. So average, taking average and divide by 2. No, it's just taking average. What am I saying? Just taking average. That's perfect. All right, there it is. That's known as taking the average. So we're gonna make this way faster. So that's what I mean. Midpoint, I won't extend or draw or even ask where is the zero located. We're just gonna take the average and see if you can do them in your head now that there's no zero involved, all right? And I will write the answer down in a different color. So all right, midpoint between two, I'm gonna give you about 3 seconds for each one. I won't count it out loud, but I'll count it in my head, all right? So midpoint for this one, think about it, and I will write down the answer in about 3. 13, that's right. What's the midpoint for this one? 7. You can check, all right? I'm double checking myself. How did we get that? Take the average. Midpoint for this one. -4. How did I get that? Take the average. All right, down here we have a -1 and 9. Okay, don't confuse these two. That's the letter A. All right, let's start with the one on the left. Midpoint, 3 seconds. 4, great. And this one won't be able to represent numerically, but we'll come back to this one. I drew two vertical lines in case that you can also use this idea in terms of y values, all right? Take the average of 7 and 3. Let's check. It take about 3 seconds. Do that one in your head. And it is 2. That's right. Okay, so let's talk about what happens when we have these variables right here. Well, what did we do? We combine them and then divide by 2. That's what average means. So the way that I'm going to represent this one is that way. I'm going to take a sum, or like we say, we add a plus b. And then remember, divide the whole thing by 2. That's the way you want to represent that. And that's perfect. You can say that is the midpoint. And for this one here, we're going to do the same. Add the endpoints. Add the endpoints. First endpoint plus second endpoint and divide all that by 2. That's great. And for this value here, same thing. We're going to take one endpoint, K, plus the other endpoint, P, in whatever order, and divide by 2. Wow, that's really cool to see this concept slowly develop. This is one of those videos where I don't mind if it's a little bit longer than I intended, but this was a lot of fun. I hope that you gained some insight and maybe conceptual understanding to this formula that you have seen many times in textbooks before, or if you didn't understand it, hopefully you gained some of that today. I'm looking forward to showing you how this connects to our series in quadratics later, but this is the end of our practice for virtually through video. All right. Thank you for watching and enjoy the rest of your day.